Hello? Hello? So just not to waste your time more and to also finish on time. So please welcome with me my ex-colleague also from the Zalando Republic, Mohamed Azouz, and the Islam Azab now from the Delivery Hero.
Hello everyone, I'm Islam Azab from Delivery Hero. I'm a software engineer there at Data Fridge. Today with my colleague Mohamed we will be talking about Data Fridge, or our data lake, which is basically the standardized pipeline for data in the company. I'll start quickly by our agenda for today. So today I'll be talking about the problem, challenges, and what's Data Fridge. And Mohamed will be talking about the quality on Data Fridge and some specifics in the fridge itself. Also, he will be showing you parts from or most of our tech stack in general. And of course, you can ask questions in the end. So about Delivery Hero. For people who are not familiar with Delivery Hero, Delivery Hero is the owner of different companies in different parts of the world, mainly who know Talabat or Outlook specifically in Egypt, Petitosia in Latin America, if you know Foodora, if you've ever ordered from Foodora before here, or Lieferherd in Germany. Also Food Panda in Southeast Asia and so on, and different parts of the world as well. We have 40 markets, we have 200 ordered restaurant partners, and last year in Q1 we had 1 million orders. Why I'm saying or talking about this? To talk about the problem with Data Fridge, why we needed something called Data Fridge, or what are the problems we have faced. So basically we had different producers for data and different consumers for data, and we wanted to make the producer produce this data in a standardized way and a valid format or schema, so that in the central part of the company we know more about our own data. And we needed to provide our consumers with different kind of ways of the data. So we needed to provide data in real-time approach. We needed to provide data in low latency APIs for people who need, like, for example, maybe aggregations or something like this, like maybe combining the order and order status. Also, it was needed for reporting. Some history behind the problem. So because we have different entities in different parts of the world, they have different kind of schemas and models and so on, and we needed to unify that in somehow. So this is one of the problems. Another problem is that we have like different central services, like for example, search or recommendation and so on. And if any of the entities, like maybe Talabat in the Middle East, wanted to integrate with these different services, it would have to integrate with each different services on its own. So it made more sense to have like more of a central service where you can integrate once with it, and the data will be available for others through any of the pipelines we said, like the real-time, the low latency, or the reporting one. Some of the challenges that we faced are that we have, as I said, many different teams in different places, many different entities, so we had to make them agree on this schema. And this was really, really hard. At some point we had like people arguing so much about it and have to like unify some of the fields, add fields, remove fields, and it's not that an easy or trivial task. Also, because of the consumer needed different use cases, like some people needed the data in real time, some people needed the data in like a low latency API that can have some aggregation or so on, and some people cared only about in the end that the data will be available for analytics. The most interesting challenge, I would say, was having a reliable system that provide all of this. So how we can keep the data, like messages are not lost sent by these producers, and like able to track it and provide this aggregation, for example, for the low latency API. So this is when the Data Fridge came. So basically we have like this normalized, consistent, near real-time platform where all the different entities we have produce the data through us, and then we provide it for the different services through, like, for example, Mohamed will describe later, but we provide the real-time, the low latency, and analytics. Real-time, low latency, and high latency as well. And now it's Mohamed.
Okay, as Islam described already before about the problem we are having multiple distributed producer along the globe, and also consumers which might need the data in single format. They don't need to basically duplicate logic with different data, different models. So that comes how we already deployed or implemented the data fridge. Data fridge is basically a pipeline of data. We are getting the data in the ingesting point, and then we are exposing the data in different ways. I would start with first the ingesting API. The ingesting API is basically a API gateway and backend with Lambda, and we are taking the data, and then we are validating the data among one schema which agreed with all the entities. So we have kind of a standard way of defining each resource. So we have order, product, vendor, whatever data we have, it's already agreed, and each one of sending us data, any entity has to agree. One beneficial also of having this is we can have multiple adapters, like we are communicating with Salesforce or any other third party, whether the company or financial team are using. So we have to bring our data from there. Then we have these adapters, which is really faster. In general, we are using in data fridge, we are using Lambda as a basic unit. We don't need to maintain any infrastructure. So, and then the first Lambda, the ingesting Lambda, pushing the data into Kinesis, which is the backbone of our data. So, and beneficial of Kinesis is we can restore the data up to 7 days. So the data will be stay there. The only bottleneck there is Kinesis doesn't scale automatically. They have plans to do it in AWS, but we have to do it manually. That's why we created another layer of SNS. So each Kinesis topic corresponding to a specific SNS topic, which is we will consume it later as one of our consumption types. Then the Kinesis, we are pushing data to SNS. This is the first consumption type, is a real time. So we have search and discovery, or any team which is like to store the data in their system and then apply whatever they need, or they change the data, then they can consume from SNS directly, and we are creating subscription for it. And then we have another type, which is a real-time API. It's basically an RESTful API providing data, and also we are providing some integration or aggregation between this data, like vendor and all of its product. And we are actually using this of one of our main KPIs is to check how much the companies spend money, the cost, and what's actually in our banks. So it's using it in financial reports as well. And then comes to the data lake, which is the last layer, is an data storage. We are using Bigquery. So in general, data fridge is a hybrid system between AWS and GCP, and the Bigquery is the landing point to the data. In the Bigquery, we are saving all historical data, all the versions for our resources, no matter what we are having. And then we can run some jobs like duplication or trimming data or whatever kind of quality checking our data. And then we are also above the Bigquery, we have ACL layer, which control who views what, because we don't need anyone to access data. Like Talabat doesn't have to see Fedora data or in Germany. Also, one of the challenges was applying the GDPR there. And then we comes to the challenges. How actually we solve the challenge. The first challenge is to have a normalized data which is already valid and all the teams are agreed. It's actually happening in the ingesting API. And the second part is providing multiple consumption types based on the use case, which is happening already in 3 different ways: the data storage, the permanent one, and the RESTful API, and then the streaming API. And inside the RESTful API, I forget to mention, we are using DynamoDB in between, so we are doing some lookups per resource in DynamoDB. And comes to the third one, which is reliability. In just an API, we don't store any data which is not valid. So all the teams or all the entities are required to validate the data according to the Swagger file or the RESTful API we are providing. And we are not responsible for this data. They have to retry the data. And then consuming from Kinesis, as we said, that Kinesis has already a flexibility of replaying data to 7 days, so our data is still reliable there. And then comes to the SNS part. We are using, whenever we are getting the data from SNS, for example, for the low latency API or RESTful API, we are using date letter queues, which is directly, if it's failed to invoke from the Lambda, which is exposes RESTful endpoint, it will or fall back to the date letter queue, and it will be consumed for 14. It will stay actually in the queue for 14 days, so we can have a chance to see what's actually wrong if it's not consumed yet. And one of the patterns we are using, so we say it's a retry pattern, and also here in the adapter we are applying retry patterns because we are owning already these adapters, so we are applying kind of a strategy for retrying multiple times. I think I already covered this in the all the challenges we have. Please let me know if you have any questions. And it comes the yeah. Okay.
Questions for now? Okay.
It's actually I'm still continuing, but if you have question, just let me know.
Small question.
Yeah, sure.
How you mentioned that in the ingestion API you have a standard schema.
Yes.
So how you handle a schema change, or if one of the entities want to have a different schema change, how you handle this in compliance to everyone else? Do you hold it and then align with everyone, or you just do something different?
Actually we have a problem while communicating with teams or entities. Different entities are physically we are forcing them to send us data. We were like, I think 6 months are asking them to send us data until it comes to be forces the data. And then this is the first step, is to convince them to send the data. And then after sending the data, we have already a schema, which is can be, we define some variables as a required variables. And then it comes like kind of order type. It's not exist in another entity. We make it optional until we have a future plan to make all the entities to apply our changes. So this is the first stage. We could say that we convince them to send the data, and then we do whatever we want from the data perspective. Depends on the actual data, because if like we have 10 entities which have the one field and only one from them, or the 11th one does not having this field, doesn't it's not reasonable that I make all the people make it optional. So this becomes first we get the data, and then we can convince them to change the schema correcting to the standard.
I still don't understand, why do you have SNS after Kinesis? Why can't you just...
The problem is having... Okay. So the question is, why do we have Kinesis before SNS? The problem is Kinesis, as said, is not an automatic scaling, and Kinesis is one of the expensive services in AWS. And then we have this SNS, which is more flexible in terms of subscription. If we have all the consumption per for example, in order stream, we have more people are interested in order stream. So if we have more consumers, it means more charts in the Kinesis topic, then more money. And if one of the teams decide to not consume the data from this, we have to decrease manually or scale down manually. So it's not flexible as you go. So we have fixed charts actually in our resources, depends on the load we have, and then we have SNS, which is more flexible in terms of creating subscription, and it's not costing us more money.
And performance-wise, it's not
Yeah, just say send a message and you receive it immediately. Nothing more. Yeah, sure.
Okay, and this red database thing is, assume it's S3, right? So we're offloading the Kinesis data to S3 or something.
It's basically the Kinesis data.
It's a Kinesis data. So
Yeah.
I mean, my question is, what is the point of using Bigquery which is outside the AWS world, because we're already having Athena.
Yes.
You can query directly S3 if you are offloading. You have the retention of Kinesis for 7 days.
Yes.
So if you are offloading to some storage layer, which is S3, which is can go on with the other artificial.
Yeah. The beneficial of having Bigquery is to query the data, especially we were storing before in S3, but the problem is we have an GDPR and you need to delete the data or PII data from each record, like order record. It has fully of customer data. We have to hash all of this data. Storing it in S3, for example, is not helping us. It's you have to do a lot of manual work. So, and the second thing is we have in the company already mindset of using Bigquery, and it's really cheap. And all the company having Google accounts, so it's easy to give permission and using it even if with access account services if you were using a GCP. Okay, can I move? Okay, how we are ensuring quality in data fridge. Physically, this is the same chart. And first, we created actually an SDK for all of our resources, and the SDK is written in TypeScript, and for every producer which use TypeScript, for example, they can use it directly, and it has all the rules which is related to the resources. And this is the first thing. The second thing is validating the data. We are validating the data in the API ingestion layer, so we don't have any corruption in the whole pipelines. And during this data, we are receiving messages of resources, and then we are wrapping the message of resource into event. And each event has metadata, which will give us opportunity in the future to track or to know who is sending us this data, which time is sending, and also it helps us in the Bigquery, for example, to partition the data per day or whatever time unit we are using it per day. Then we have actually currently we are not we still don't have data duplication layer, or we are planning to have it to remove all the duplication, because sometimes in the API ingestion part, if it's failed, the producer try multiple times, and we already noticed that some teams are sending us more data. Okay? I remember I have one row which is already pushed 27k times. I don't know how they implement it, but yeah, we have this already. Yeah, and then we have transparency with other teams, which is the producer and consumers. The first thing is we have already dashboard for validation, so each team has already how many valid events, unvalid events they have, and also we are persisting the 400 events in Bigquery, so we can report have reports and dashboards for how many events or who is sending much non-valid events. And then inside the system itself, we have still it's not efficient so far. We already these service level dashboards, which is service level indicators and objective, and still we are having kind of service indicators which show what's going on inside the services, but we don't have objective so far. But this is the future plan, to have kind of objective, how many successful, how many error rate, and what's the availability percentage, and so on. And the last thing is data quality dashboard. Data quality, the purpose of this dashboard is to show how many valid data we have, how many unique data is stored in Bigquery, and it also really beneficial for the company C-level people to see how many data we have and how quality it is. And I forget one thing, which is Bigquery also it's used to retrieve reports to the C-level or the company managers to see how the data is performing. And then to the end, we this is the tech stack we are using. We are all the teams has its own. Everyone in the team has its own Terraform state file, so they can or we can deploy our own environment. And also we, as we mentioned, we are using hybrid system, AWS and GCP, and we are using Lambda API gateway for getting the data or exposing data. And then for data management, we are using several services in AWS and Google. One point which I would like to share, we were using data flows, which is really expensive in GCP, and then we remove it, and for mostly of could be like 80% or 90% of our resources, we got around 80% off of our cost. So it's really expensive because we have data flow and BubSub as the bridge between AWS to the GCP, and data flow to push the Bigquery. We are using now Bigquery streaming, and the Google Data Studio, we are using it for dashboards. And mainly we are using the languages. We are using Java and TypeScript. Java is we could say 95 TypeScript, 12% Java, only one application anyway. Yeah, and for monitoring and logging, we are using CloudWatch, and X-Ray is really helpful. X-Ray for knowing where is actually the event. Yes.
Well, thank you about this nice presentation. I just have a question. I noticed in the title that you guys canceled the term data lake and added the fridge. I assume there is a reason for that. Can you tell me why?
It's basically we are implementing data lake. So it's a data lake. We are preparing data, or the plain data to provide to multiple consumers, and we are doing one thing more, which is validating the data. We need the data to be valid real time. We don't need to store in our system an non-valid data. In terms of we have to agree all on this specific schema to be valid. Yeah, some other implementation to the data lake, they push to one bus stream, and then they check the data if they are valid or not. But we are checking it real time, as it's here. Here, the ingestion API, we don't take any data which is invalid. Yeah.
So, first of all, that looks very familiar to what we had in Zalando like a couple of years ago. I have two questions. The first one, why using Kinesis? Why didn't use Kafka? Then you won't need to do a deduplication. Also, you can benefit from K-streams to do any kind of pre-processing before actually pushing the data to different streams. That's first question. Yeah, the second question, how do you handle if someone didn't comply to a certain kind of schema, and they didn't do this and they sent it to you anyway? So how do you handle this? Do you reject it as a bad request and then they need to handle it themselves, or?
Yes, for the second question, yes, we.
The question, please.
Okay, so Khaled asked two questions. The first one, why, how do we trade with bad requests, or if one entity decide to send us a schema which is not defined in the endpoint? For this question, we don't take the resource or the message, and we basically discard it and send it as a 400 event, and we are taking the payload or the validation problems to the Bigquery, and then we have kind of alerting system to see how many what's actually the problem, and then we can communicate with them. For the second question, why don't we use a Kafka instead of Kinesis? The point is here is the team initially started to have low budget, if we could say. We don't need to have extra operational cost. We need to use directly the plug and play thing. So we choose Kinesis. We don't need to maintain anything, and we don't need to have also more people, which is not actually part of a team to work. We don't need more resources. We need focus more into the problem, solving the data to different consumers more than having an operational cost. That's mainly it. Of course, we could think of Kafka in the future, but currently we don't need actually Kafka.
One more question. I saw you're using DynamoDB.
Yes.
DynamoDB is known to be a bit expensive if you have so much data.
Yeah.
So do you use dynamic Dynamo with it, which is dynamically adjusting the reads and writes?
Yes, that's actually a good question, because AWS before we were using this capacity, read and write capacity, and now they launched it lately 2 weeks ago or 3 weeks ago, this on-demand scaling. We were using read and write capacity, and it's really awful in terms of peaks, and it takes time to scale. But now it's on demand. It can scale from, I give you like 100 to 7,000 in like 10 minutes or even less. So it's really fast in terms of scaling. We are using it now. It's not that expensive. I'm sorry, I didn't say the question. The question was why we are using DynamoDB, because it's expensive. And how we are controlling the scaling in DynamoDB. We were using DynamoDB for reading and write capacity, which we have to set it before, and we have to set maximum read and maximum write capacity. But the problem, we had a lot of problems with scaling, and it doesn't scale that flexible. It needs time to scale. Now we are using it. They launched it like kind of 3 weeks ago, on-demand scaling. So it can scale without any pre-configuration on.
Up and down.
Yes. Yeah.
Okay, I have a very simple question that is very crucial. Where is exactly the storage layer for the data lake? I mean, data lake is a storage layer.
If you want.
So here you have history, but you also mentioned Bigquery. Bigquery is known that like it's a query engine, so there is nothing storage in there, and it's similar to Athena. But where is exactly the data? I didn't get where is the data. I mean, you mentioned Kinesis as was having retention of 7 days, but where is exactly the data for batch processing? If I am a consumer, I want to have some batch ETL for the data. Where is exactly? I didn't get.
So the data exactly as Mohamed was describing. Okay, so to repeat the question is where exactly is the data stored in our system? Like where do you find it if you want to do batch processing on it? Is it clear? So as Mohamed was saying, we provide our data in 3 different ways. So the streaming one, which is down there on the right, and there's the low latency API, which is for the like if you have like an API, RESTful API. And in the end, we have everything in Bigquery. So as Mohamed was saying, we store everything in Bigquery. Nothing gets removed from here at all. Even we have it integrated, for example, with the GDPR service where we remove any PII data or anything. But like if you want to find any, let's say, historical order or something like this, or any historical vendor or something like this as well, you would get it from this point.
So you are taking the data from Kinesis through a pipe to Google storage layer, not Bigquery itself, because Bigquery Exactly right. So the
Yes.
query is only a query engine. It doesn't store any data, which is actually storing using Google storage. Instead
No.
of S3. So yeah, I mean, that's
Probably,
Yeah.
probably whoever is using Bigquery is actually creating an ETL to
create the
consume
table.
from the storage and actually get a view out of in Bigquery and then
Yes,
use
that's
Yes,
what
yes.
I said already. We are creating a layer for views to control the ACL for the data, and each consumer has its own view to consume specific data. So we have another layer above the BigQuery to give the user data, and then you can do whatever you want with the data. We don't own the data. You own the data, or the producer owns the data, so they can do whatever they want.
Thanks for the talk and have the questions quickly. First question, what is the difference between data fridge and data lake?
Yeah. Okay, so John was one thing about the naming of fridge. So basically, it's just like a nickname or like a code name for the team. So the basic idea was like for a fridge, it's you go to the fridge, open the fridge, get whatever you want, and the data is there. So this is like how the fridge is replacing the word lake. Sorry? Yeah, there are a lot of pizzas.
Second question. I see the validation process after kinesis, right?
No, actually the validation process happened in the Lambda where we do the ingestion. So it's before we get the message into our system at all. So as you see here, like we get the message in the Lambda, we do the validation through the SDK or the
And deduplication after kinesis, right?
Yes, the So one thing that happened, the data deduplication, we have it only if like the message happened in like 10 minutes time frame. With Google Cloud, there's like this inserted ID. If it has like the same inserted ID within the same time frame, we have it. But what Mohamed was saying, that we need it in a more sophisticated way, not just the GCP way.
My question in this part.
Yeah.
Do you face like the before any problem in SNS as well? Some duplication and need to move this layer, data deduplication after SNS, or?
So on the SNS level, you wouldn't do any deduplication because you would get the message as soon as it lands in SNS. So you can't do it unless we do it on the ingestion layer. If we know somehow that this message we got it earlier, then now we can just drop it and not pass it around. But like to do it from the SNS part, I don't think it's feasible to do it. It would need that on the ingestion API, you would have to do some querying, check that the message existed or not, and then.
Okay.
Okay.
I have one.
He has last question. What last question?
Just two more questions, okay?
Okay.
You okay?
You got ready too. So there are three who want to ask.
Now, as I understand, the data moved from Kinesis to another cloud provider. So this is some latency happen with this operation. So why not to store direct to S3?
Yeah.
And use like some dynamic schema approach to solve the problem in ingest API and keep all the data dynamically changed.
Yeah.
With the schema level using something like Glue, and then.
Okay. So the question is, why like have this connection between like AWS world and GCP, and like how to avoid this latency? Yeah. So one keyword that I would like to highlight when we mentioned is we have like this near real-time pipeline. We don't need for our use case that the pipeline would be 100% real-time. So for our case, it was quite enough that we have like this delay would be okay. And as far as I remember, you were saying that the delay usually at most is like around 1 or 2 seconds. So we can live with it. It's not that bad anyway.
And also, It's not the purpose of purpose of having it. It's not using it in a critical process. Like if you are depending on your website or something, so it's basically used for offline analytics or offline data processing.
I have one question. If I understand this correctly, there are some resources which they enter the data and some consumers, right? Like
Yes.
access this data.
Yeah.
How do you make sure that the consumers should have access to this data, not any other data? Because I believe you collect from 6 brands and you put in one place, right?
Okay, so as Mohamed's saying, and some part in the BigQuery part, it's easy to do this with like the giving user specific access to specific views.
Okay.
So this is on the BigQuery part. On the streaming part, we can do this easily with SNS filtering. You can have like some kind of filtering on the message based on like, let's say the entity name or something like this. So Talabat will get the messages from Talabat, or Bitdosia will get only the message related to the post, not everything. On the low latency API, it's basically like API access. So your token is available to access this kind of vendor or this kind of entity. So you can restrict it with this RESTable API access and so on.
There's two.
Yeah.
Security authentication, but
This is GWT
JWT, yeah.
currently. Yeah, there's two.
One question.
In the beginning, you want to handle like data privacy for each producer. So how do you handle data privacy where all events are placed in Kansas streaming pipeline?
Okay. For Kinesis, we are having. Okay, the question is how we are handling the data privacy while we are using Kinesis. So each Kinesis stream has only one responsibility or having only one resource. So for orders, we have only one resource for or one Kinesis stream. For others, we have one-to-one relation between the resource and Kinesis. So we don't have multiple data in one stream. The same as SNS. Only streams which is having kind of aggregation, vendor and product. So we are storing this in a specific schema. But other than that, we don't have multiple resources in one stream. Does that answer your question?
Yeah, but the same resource can be produced by multiple producers.
Yes, we are having in the end tables, and each table also for specific resource. And then after the table, we have views for each consumer for its use case. So for example, like discovery search people, they need all the data from all the brands. Then we have to ask all the brands individually, do you want to give this team access to their data or not? The problem is currently we need to automate this process. So we don't need an extra step from human to check the other teams. We need kind of a front end to display who can see what. It does this.
Also, one thing, Kinesis is not available externally for anyone. It's just internally for us. So because the available streams like only through SNS, and this is how we control, for example, the real-time data, how it goes. So having all the data from different entities or different producers in Kinesis will not affect the privacy of the data.
Okay, so all consumers are controlled by delivering you.
Yes.
Okay.
Yeah.
So yeah, I think okay. I broke some. So,
Do you have any more questions?
if you have any more questions, you can. No, you can do it after that. Especially you. So yeah, thank you guys.
Thank you.
It was a great presentation.